Well, welcome everyone, and thank you so much for coming. I'm Ellen Letvin, and I'm the Vice President for Science and Education at Pacific Science Center, and I'm also the Director of the Seattle Science Festival. And I'm so glad you're here, and I'm happy to welcome you to the closing night of the Seattle Science Festival. Tonight we'll have two world-renowned scientists and outstanding communicators, Richard Alley and Kevin Trenberth. And then we also have award-winning climate journalist and Andrew Revkin, as well as a performance of a work by the Seattle Opera. This is the last of, or tomorrow will be actually the last of 11 days of the festival that have been basically trying to elevate awareness and interest in our community about how important science and technology are to our community's culture and to its prosperity. So I hope some of you have had the chance to attend some of those events. They've been pretty amazing. But a festival like this really requires too many people to thank specifically, but I have to say we have over 90 collaborators, more than 100 volunteers, and many sponsors, but in particular I want to do a shout out for the Seattle Center and the Boeing Company that provided invaluable support, and there are other sponsors listed in the program, so please check it out. But please join me right now in giving all of them a hand. So now I would like to introduce tonight's MC, who is Usha McFarling. She's a Pulitzer Prize-winning science writer who is currently an artist in residence at the UW in the Department of Communication. Usha? Thank you all.
Welcome. Climate change is one of the most critical issues we face. It affects us all. Because of its size and complexity, because it's tangled up in fights over values, because it has no discrete solution, it's often referred to as a wicked problem. One of our speakers tonight, Andrew Revkin, goes so far as to call it a beyond super wicked problem. It's challenging on many fronts. It's challenging scientifically, politically, economically, educationally, socially, whether on cable TV or in the blogosphere. It's clear that this topic remains charged, divisive, and often very, very ugly. Finally, it's difficult psychologically, where it often sends people into feelings of denial and wanting to put their heads in the sand. This turnout tonight shows me we're not going to do that. You're all here because you want to become better informed, to understand this issue, and confront it. And we are so fortunate tonight to have a distinguished lineup of speakers. All three have dedicated decades of work to this topic. They have a deep, deep knowledge and understanding of these issues and the highest level of integrity in their work and a huge commitment to public engagement and understanding. We're going to cover a lot of ground tonight. We're going to talk about where we stand, what may lie ahead, and what we as individuals can do about some of these issues. We also want to engage with you, the audience. The speakers will be taking your questions. You can tweet them at the hashtag SSF or write them on cards that are near your seats, and they'll be collected at the intermission. So if you have any questions for the current speakers or for Andrew Revkin, who'll be in the second half, make sure to get them to one of the volunteers during the intermission. We'll try to get to as many as we can, and those we can't, Andy's promised to follow up on his blog, .earth, and through Twitter. So now I'd like to introduce our first speaker. Richard Alley is the Evan Pugh Professor of Geosciences at the Pennsylvania State University. He's a member of the National Academy of Sciences, the American Academy of Arts and Sciences, who has received too many awards to mention for his scientific achievement, teaching, and public outreach. His work to study large ice sheets has literally taken him to the ends of the earth. He's best known for his work analyzing the composition of ice cores up to 2 miles deep, both Greenland and Antarctica, to reveal that climate change has occurred very abruptly in the past. He's currently studying something quite important, trying to determine if those ice sheets risk falling into the oceans and flooding our coastlines. He is the author of The 2-Mile Time Machine, which was Phi Beta Kappa's Science Book of the Year in 2001. He's also the host of the wonderful PBS show, if you haven't seen it, Earth, the Operator's Manual. This all sounds a little bit dry and professorial, but Richard Alley is anything but. because of his liberal use of Johnny Cash imitations, his employment of both his bald spot and dance moves to demonstrate the Earth's orbit. He has been described as a cross between Woody Allen and Carl Sagan. Please welcome Richard Alley.
Wow. Hey, I can almost see some of you, but welcome. Science equals Seattle. What a great line. And Seattle equals science. Yeah, say so. Come on. We actually, you get the newspaper and it says, wow, the salmon are running at the dock, up at the locks. And so we went up to the locks this morning to see the salmon running. And what a wonderful place. And I've got a little summary over here in the corner in case you fall asleep later. What I'm going to tell you and what you're going to hear from the rest of the people here is that climate science is actually solid. Energy engineering is coming along fast. And if we use those with what we believe in and where we want to go, we really can have a better future. Not a worse one, a better one. But I'm going to show you why we need a little help from Abe Lincoln to get there. So let me start you with a story. This is true. A few years ago, we were getting concerned calls from a group who had realized that it snows in Greenland and Antarctica. And it snows, and it snows, and it snows, and the world's going to roll over. And the only thing to save us was if we took the Antarctic ice sheet and hauled it to the Sahara Desert and melted it and watered the desert. Okay, come on. Okay. Be very, very clear. You don't have to worry. The world is not going to roll over. All right? Yes, snow falls on top, and it makes a 2-mile thick, 1-continent-wide pile that spreads under its own weight. And off at the edge, it makes icebergs or it melts. And recently, it's been spreading and melting and making icebergs faster than it snows. So it's going the other way. But don't worry, okay? It is not going to build up and build up and build up and roll over. But this idea, it turns out, was part of science. And there's a whole lot of ideas like this that we sort of think of now as science zombies, because they were part of science, and then science did what it does. Here's an idea, here's another idea, here's another idea. Let's make predictions and see which one comes out. And the losers, we set aside. But what often happens is that they wander off somewhere into the far reaches of the public, and they don't die. And then they come back as zombies, okay? CDC gave us our zombie here. So where did this one come from? This is fascinating, right? 100 years ago, explorers are opening Antarctica, and they come back with fern fossils. That one that you see right there, I actually collected on the tip of the Antarctic Peninsula at a place called Mount Flora. And so the Swedish Antarctic expedition in 1904 found that site first. And they said, whoa. I'll show you the place today, by the way. This is what Mount Flora looks like today. The fossils came from right up here over my head, right there. Okay, this does not look like a place for ferns. And they figured this out 100 years ago, and they said, okay, what the heck is going on here? We had ferns, and now we have jumping penguins. Something's weird. And they started trying ideas. And one of the ideas was, well, maybe the climate changed. And one of the ideas was maybe the continents moved. And one of the ideas was maybe the continents moved all together. And that's the world rolling over. And 100 years ago, this was science. But then you say, what do they predict? What does it lead to? And the answer pretty much is that, no, the world didn't roll over. And yes, continents drift. And yes, climate changes. And a lot of it was CO2. And so we did science, but like I say, the idea didn't really die. It became a science zombie, brought back to life. Now, as a scientist, it's sort of cool that there's somebody out there that's actually interested enough in what we do to wake this zombie up and check on it occasionally. And the truth is, we as scientists do occasionally go check on our zombies, just to be sure. It actually turns out now the ice that is melting on the Earth is not exactly at the poles, and it's sort of changing the mass distribution of this spinning planet that we've got, and it is wobbling just a little. And the North Pole is moving about that far a year. And so it's nice to keep track of this, but the world isn't rolling over. Okay, so don't worry about that. We're fine here. But I use this as an introduction because there are zombies that matter, as well as zombies that are sort of entertaining here. Okay, now I work on climate science. You'll meet Kevin Trenberth, who works on climate science. I have been fortunate, honored, that what we've done is interesting enough that for the last 20 years, occasionally somebody who matters as a policymaker calls up and says, tell us what's going on. And so you go down to Washington, and what we do, meet on both sides of the aisle. This affects everybody. It's not just one side of the aisle. And we talk new science, and we talk what it means, and we talk what it might lead to. But for 20 years, the discussion has been dominated by zombies. And the world rolling over is some amateurs who are having a little fun, but these are actually people doing really things that matter. And they've dominated by zombies. And so we live in a world where things that scientists looked at as real science and then found lost migrate away, but they keep getting waked. Somebody wakes them up, and we put them to sleep, and somebody wakes them up. And it's all sorts of things. I'm going to walk you through one of them here, okay? The world is warming. The world is warming, okay? And we know that from thermometer data as analyzed by NOAA and by NASA and by the UK group and by the Japanese group and by the folks at Berkeley that got some money from private foundations, including some supported by fossil fuels. If you take the thermometer data and throw away all the ones in the cities and just look at the country, it's warmer. If you just take the thermometers in holes in the ground, it's getting warmer. If you just take the thermometers in the ocean, it's getting warmer. If you take the thermometers taken up on radiosondes, warming. If you take the thermometers looking down from space, warming. And different groups on different continents with different funding all find warming. Go ask the snow and ice, not the middle of East Antarctica at -50, but the snow and ice that's close to melting. And the great majority around the planet is melting. I live in a different gardening zone than when I moved to Penn State, because where the plants and animals live and when they do things are changing in the direction of warming. There is an interwoven tapestry of evidence that shows warming very clearly. Okay, now here's some data. Year 1960 on your left, 2010 on your right. The red dots are year to year, and the blue line is the regression. It's getting warmer. But let me do a zombie for you, okay? Suppose I wanted you to not worry about the warming. What could I do, okay? Well, what I do is I'd say, yeah, it used to be warming, but it stopped. Global warming stopped. Google that, you'll get lots of hits. Bing that, and you'll get lots of hits. Don't worry about it. I have spent 20 years about helping put this zombie back to bed and be very clear, you know? So how do you do it? And let me walk you through. Here's the data, remember. It's getting warmer. But what do you do if you want to wake up this zombie? Okay. That's me. Okay. I was born in 1957. If you take the data right after I was born and run a line through it, what do you see? It was getting cooler after I was born. I'm cool. All right. My dear wife is here. We're still happily married. We got married in 1980. We had to stay warm somehow because it was getting cooler after we got married. Got a job at Penn State, still there, 1988. Not much cooling, but just a little bit down. There you see it, right? We got the kids and we came out to the west to see the great mountain parks, and, you know, it was at the start of a cooling trend when we came out west. And, you know, they named a glacier after me in Antarctica. Very short, very steep cooling trend after they named a glacier after me, right? And her daughter, who's here, she's a middle school science teacher in this area up the ridge. And she became a Penn State student in 2005 at the start of a cooling trend. So what do you see? My whole life it's been getting colder. Oops. Okay. You have policymakers who are making laws based on saying, oh, global warming stopped. This is not all fun and games. It's real. There are people today, policymakers, people who matter, who are saying, hey, global warming stopped, and that's what they're doing. Okay, now Kevin Trenberth, who will come out next, has done a lot of the research on this. He'll tell you more about the science of this, so stay tuned. But this global warming stopped is a climate zombie. Okay? Yes, the world is variable. We have El Niños and La Niñas and volcanoes and changing sun, and then we're pushing it up with CO2. And so it staggers up. You watch a dog out on a walk, and boy, you got to watch a while to see which way it's going. You watch the person walking the dog, and you know where they're going. CO2 is the person walking the dog. Okay? So the world really is warming, and it's mostly because of CO2. I'll give you that in just a minute here. But what do you do if you want to wake up the zombie? The year that it warms, shut up. The next year, global warming stopped. It's been going on my whole career. All right. So what do we do about zombies? How do we cure zombies? Abe Lincoln, zombie hunter. All right? Yes. Okay, this is true. Okay, let me tell you a story. Civil War breaks out. What had been the U.S. Navy now is the Union Navy. They got a lot of ships in the South. They have fewer sailors. They sail as many of them out as they can. They burn the rest. One of them is something called the Merrimack. She's sitting on the bottom. Bright people in the Confederacy say, hey, there's a steam engine in there. But she lacks a superstructure. What do? We'll raise her. We'll put a deck on. We'll cover it with iron plates. They shoot at us, they'll bounce off. We're going to put a ram on the front so we can ram it into the side of wooden boats. We got steam engine, we're going into battle. Okay. First battle, she sinks 2 Union ships to the line. She's off to the third one when the tide goes down and the sun goes down. Overnight, what happens? The Union brings in their ironclad, the Monitor, and the Monitor, Merrimack, Virginia, fight to a draw. And inside a very few weeks, every navy in the world is building ironclads because the world has changed. And at this point, you need some help. Because what's happened? You're going to sail to the next battle. It's a dark night. You don't want to run into the reef. And you just put giant slabs of metal next to your magnetic compass. Which way is north? All right? And what they did is turn to a new secret weapon. The National Academy of Science. All right? So what is this? If you're a scientist, part of our job is to argue. Part of our job is to wake up the zombies occasionally just for a little bit and see what they're doing. You're a policymaker and you raise the lid and you watch what we're doing and you slam the lid back down. And so Lincoln said, the House, the Senate, Lincoln the same day, say, these people owe and they want to help. They're going to come out of their box from arguing, and they're going to sit down with the public watching without being paid for this, and they're going to provide the best advice they can on what's solid and what's speculative and what's silly, and we're going to use this and let them get back to work. And that's what they did. And what they ended up doing is saying, you know, that compass, figure out where north is off the boat, put it on the boat, it goes a different direction, true it up with some little magnets. That works. The other things they're trying to sell you don't work. And the North navigated through the rest of the war knowing which way north was. Okay? So this works, all right? Wilson, World War I, says we need advice from the Academy. Eisenhower says we rely on the Academy for advice. Bush Sr. says we rely on the Academy for advice. Bush Jr. goes to the Academy to ask about climate change. All right? Now, it's not just us. There's national academies around the world. And what you find is that since the late 1970s, ours and all the other major ones have been saying exactly the same thing about CO2 and global warming. President Bush Jr., George W. Bush, said, we'll get some more reports. We'll get CCSP as well as the National Academy. Got the same story. Okay, the UN, we'll get some reports. Got the same story. All right, this is very confident, very repeated. Why? Because of physics. All right, we've known about this for more than a century. And it really got worked out by the Air Force right after World War II. Now, the Air Force was not doing global warming. They were doing heat-seeking missiles. You want to shoot down the enemy bomber, you can see the heat radiation. You follow it, you blow them up. But if you use the wrong sensor, you can't see the heat radiation because CO2 blocks the view. There's a very tiny amount of heat coming down from enemy bombers. There's a lot of heat coming up from the sun-warmed Earth. And you put that physics into the climate understanding, and global warming, turning up the thermostat is unavoidable. This plot over my head right here is the Earth cooling off from that sunshine that heats us, and this divot over here is what CO2 is blocking. And if there were more CO2, it could block more. That's why we believe in global warming. It's physics. There's no way around the CO2 turning up the thermostat. That plus 20 tons of CO2 per person a year in the US in round numbers, and we've got an issue. Okay? Climate science. 1800 is over here, 2000 is over there. Greenhouse effect, 1824. CO2 is part of it, 1859. Human CO2 from fossil fuel burning is going to raise the temperature, 1896. Compare that to these newfangled science things. Like Einstein and your GPS, he's newfangled. Like quantum in your computer, that's newfangled. Like plate tectonics from continental drift and why Rainier is so beautiful and why it's worth knowing about it. That's newfangled compared to this old-fangled stuff from climate science. Now, if we had another, you'll get some of this from Kevin. I hope maybe we'll get some of this in the questions. We had another hour. We'd walk through a whole bunch more things because it's absolutely fascinating. But the warming is primarily from fossil fuel CO2. We are burning fossil fuels about 1 million times faster than nature saved them for us. We have to do something else eventually. This cannot go on forever. If we burn before we learn, our grandkids and their grandkids have no safety net, and they're living in a world that's hard to live in. And if we learn while we burn, there actually is scholarship that we end up with a bigger economy than ignoring this, with more jobs, with greater national security, with cleaner environment, with saving rare and endangered species, and it's more consistent with the golden rule, and that essentially we can power everyone on the planet forever. And that's really what's floating on the picture here. And so be clear, this doesn't tell you what policy you have to adopt, but you darn well know that science works. That's why you're here, right? I got a cell phone in here somewhere. It really does have a GPS with Einstein in it. It really does have a computer with Bohr in it. And if you ask the bridge club or the tennis team or the Senate to turn a cup of oil and a cup of red rocks and a cup of green rocks and a cup of sand into that GPS and that computer in your cell phone, they would fail. And if you ask scientists and engineers to do it, they did it. And you know that as well as we're here. And this is very clear, that including science in our planning on energy and the environment really can make us better off. We're not fading into hiding in the dark and not doing anything. The opportunities are just fantastic. And Lincoln gave us a lot of the way as a zombie hunter. This one, before he's president, Lincoln is the only president who held a patent for an ingenious device to float riverboats over shallows. He's given speeches on the value of the patent system, on the value of science and engineering and learning and helping people. And among the things he speechified on is this one. He says, the wind, as yet, is an untamed and unharnessed force, and quite possibly the greatest discoveries to be made will be taming and harnessing of it. Wind and water and sun, and there's far more energy available than we use. And Lincoln knew it. So he hunted the zombies, and he showed us what to do instead. So let me leave you with a picture I took in Greenland of an iceberg and a rainbow. Can we have a world with icebergs and rainbows? Absolutely, unequivocally, yes. Thank you for coming out, and Kevin will be next here. You're going to enjoy this.